All right, hi guys. If you're watching this, hopefully you have just gotten this Universally Yours activity. So there's some background, there's a video, and some pre-lab questions you need to watch and do. So do that before watching the rest of this video. If you've already done that, awesome. I'm going to have you put your answers in for these first pre-lab questions right now. All right, so the purpose of this lab is we want to figure out how would we calculate the force of gravity. So if we've discovered two planets far, far away and we knew their masses and their distance apart, how do we calculate the force of gravity between them? Or if we want to figure out what's the force of gravity between the Earth and the Moon, how would we calculate that? So your goal in this lab is to discover an equation that would allow you to do this. In other words, you want to graphically and mathematically model the relationship between the force of gravity, that's going to be your dependent variable, and three things: mass of one object, mass of the other object, and the distance between the center of those two objects. So that goes on this line right here. Mass of one object, mass of the other object, and the distance between their centers. So what we're going to do is use this simulation down here. So you can either Google search PhET Gravity Lab, or you can just open one of these links. Okay, so when you open it or you Google it, it'll look like this. You can do this on your iPads. And so you click play on the activity, and here's what you have. You have two masses, M1, M2. You have a ruler that you can move around, and you have the force on M1 by M2, force on M2 by M1. These masses are very small. However, they're equal, which they should be, right, because of Newton's third law. So I can move these masses closer together, and the force gets bigger. I can move them farther apart, and the force gets smaller. I can also change the mass of these objects. Force gets bigger, force gets bigger. You see that guy has to pull a lot harder to hang on to it, less hard. Okay, so you can see the kind of the relationships already, but again, we want to graphically and mathematically model them. So here's what you want to do. Set both masses to 1 kilogram. So I'm going to set both of these to 1. And you want to move them so they're exactly 1 meter apart. So I'm going to drag my ruler up here, and I want to put the center of them exactly 1 meter apart. All right, I'll know it's 1 meter when I get this 68.0000000000068 newtons. That's what I'm looking for to know I'm in the right starting place, and this is all on this worksheet here. So you're investigating how changing different variables affects that force. The force is really small, so we're going to measure in piconewtons, which is times 10 to the negative 12th. And so if you've set it up correctly right now, it should say this. And we're going to call this 68 piconewtons because it's 68 times 10 to the negative 12th. So that's going to be your first data point. Now, depending on your birth month, you're going to vary a different variable. So you might be doing mass 1, mass 2, or distance. So then I've set up some columns for you right here so you can start putting your data in. I put 0, 0 for all of us because if there's 0 mass or 0 distance, there's going to be 0 gravitational force. And then I put 1 and 68 piconewtons in there as well because that's our starting point for all of them. Couple things. If you're born in January through August, you're changing the mass here. Okay? So you see the mass of this blue sphere getting larger and larger. Now something to notice is if I go above around 40 kilograms, it starts to move. So now the distances are increasing. We're no longer keeping distance constant. So this isn't a valid experiment. So you want to keep somewhere between 1 and 40. You want to keep those 1 meter away from each other. And this is kind of touchy, so you want to be careful on that. So if you're doing these two columns, you want to be careful of that. This column for distances, you're going to be increasing the distance. Big distances don't work very well. So if you start to look at the number, that force of gravity there, staying 1, 1, 1. So for like this entire 2 meter distance, it's still only 1 piconewton. Well, that's not super helpful, right? It's just kind of leveling out at that point. So we want to keep your distances between 0 and 2 meters. So you want to find 8 to 10 different distances here to measure. All right, so you're going to fill in your data table. You're going to graph this using graphical analysis, linearize it if needed. Unfortunately, our dear friends over here who are doing distance, you have 2 linearizations you need to do to get this linear. Okay, so if you don't find those, you're not doing it right. And then last thing, we're going to write a physics equation. Make sure when you write your physics equation, your slope should have units on it. Other than that, you guys are all set to do this. When you come in tomorrow, you better be ready to whiteboard this, okay? So I expect this to be finished. So if you have any questions, email me or watch this video again. Thanks for watching. I'll see you guys tomorrow. Bye.